Now, consider a unit circle. If I pick a point xy on the actual circle, the radius is 1. If I look at the actual traditional xy, there's my x, there's my y. So, if I take the cosine of theta, that's the adjacent over the hypotenuse, but the hypotenuse is the radius, which is 1, because it's a unit circle. So pretty much this says x equal the cosine of theta. And similarly, if I take the sine of theta, that would be the opposite over the hypotenuse. But again, it's 1, so y is the sine of theta. And if I take, so pretty much before I go on, I could take the point xy and replace it by a cosine of theta, sine of theta. You could always do that provided it's a unit circle. Otherwise, you have to multiply by r. So, assumption is that we are dealing with a unit circle. Tan of theta would be the opposite, but again, we have just concluded if this is the triangle, this is 1, this is my x, but we said x was the cosine of theta, and this is my y, but we said y was the sine of theta. Tan of theta is the opposite over the adjacent. We know that secant of theta is the hypotenuse over the adjacent. Cosecant of theta is the adjacent over the opposite. And cotan of theta is the adjacent over the opposite. So I get the reciprocal identities. And if I take this side squared, but instead of x, it's really cosine squared of theta, plus this side squared, which is sine squared of theta, that's the y, that equals 1 squared, which is 1. That's the fundamental, that's a Pythagorean identity. And if I divide each of those by cosine, so if I take divide by cosine squared of theta, cosine squared of theta divided by cosine squared of theta is a 1. Sine squared over cosine squared, well, sine over cosine is tangent, so sine squared over cosine squared would be tangent squared of theta. And 1 over cosine would be the secant squared of theta. And if I go back to this equation, and I divide everything by sine squared of theta, cosine squared over sine squared is cotangent squared of theta. Sine squared over sine squared is a 1, and 1 divided by sine squared is a cosecant squared of theta. And that's how trigonometry defines all of these angles. Now, since this is x and this is y, we know in the first quadrant they're all positive. In the second quadrant, only y is positive, but that's the sine. In the third quadrant, sine and cosine are negative, which means the ratio of those, which is the tangent, is positive. And in the fourth quadrant, x is positive, but x is the cosine. And this is where the old students take calculus comes from. Now, if this is a unit circle, this point is negative 1, 0. This point is 0, 1. This point is 1, 0. And this point is 0, negative 1. Now if I proceed and look at some of these, it says find the value of the rectangular coordinates of the terminal point x on the unit circle. Okay, let's see how this plays. So if I'm looking at example A, let's see how that plays. Pi is right there. This point is negative 1, 0. Find the value of the rectangular coordinates of the terminal point, negative 1, 0. That's all we need to know. If this point is on the unit circle, what are those points? Here they are. What if it's 3 pi? Well, isn't 3 pi identical? Isn't that the same thing? That is, wouldn't you rotate 1 pi, 2 pi, 3 pi? You're at the same location. And there it is. Now, what if I'm looking at 5 pi over 6? In reality, this is what I'm supposed to do. I am supposed to really say, well, 5 pi over 6 is right there. You are on the unit circle, of course. So you're going to stop right there. And you're going to say, but wait a minute. If I use my reference angle, if this is 5 pi over 6 and this is 6 pi over 6, isn't that pi over 6? So let me get this part out of the way. I'm looking at this triangle, and I notice in this triangle, this is 30 degrees. So I know if this is 1, this is 2, this is radical 3. But this is a unit circle. How do you force this to be a 1? Well, divided by 2. What's the price? So there it is. And what am I looking for? I'm looking for the x and the y. Isn't the x the cosine? What's the cosine of this angle? The adjacent. And remember, in this quadrant, x is negative and y is positive. So in this case, cosine is negative radical 3 over 2, and sine is 1/2. We could do it that way. We could also do it another way. We could say, look, a reference angle of 30 degrees so we know that cosine is radical 3 over 2 and the sine is opposite over 1/2. And in this quadrant, we could memorize that only sine is positive, which means cosine is negative. That's a lot quicker. So if I look at part F, I could get to the answer right away. I am aware at that terminal point on the circle, I have an x value of radical 3 over 2 and a 1/2. Because we've shown no matter what, if you're talking about 30 degrees, 1, 2, radical 3, no exceptions. You want to make that a 1, you can. That's easy. That doesn't change anything. That makes this a 1, radical 3 over 2, and a 1/2. The ratio of these sides will never change because they're similar triangles. So it's easier to just stick with what we know initially and make use of the triangles. Now, trig doesn't use triangles. It really maps the triangles on the unit circle, but since we already covered that, a combination of trig and geometry will make this really easy. Where is negative 7 pi over 6? The location is a must. If I run in negative rotation, isn't that negative pi, which is 6 pi over 6? So isn't negative 7 pi over 6 a bit past that? And isn't it only the sine is positive, which means the cosine is negative? So using the unit circle along with the two triangles is pretty much the best way out of this. Let's see if that works. How about pi over 3? Pi over 3, again, I could really show you this one more time. Maybe that will make it look easier, but I want to make sure you understand how they're doing this. This is how they want us to do this. They want us to run on a unit circle, and they would like us to run from 0 to negative, this is negative 3 pi over 4, this is negative 4 pi over 4. If you stop right there, they would like us to know what is the x and the y. Well, keep in mind, that's a reference angle of pi over 3. That is a reference angle of pi over 3. Well, pi over 3 is 60 degrees. There's 60 degrees. I know cosine is the x and sine is the y. Cosine is the adjacent over the hypotenuse. It's 1/2. And if the triangle was as it was initially, what difference does it make? 1, 2, radical 3. Cosine of 60 is the adjacent over the hypotenuse. That's not going to change. Sine is the opposite over the hypotenuse. And in this quadrant, we know this is the only negative quantity, and there it is. And if I run to 13 pi, now any multiples of pi, the triangle can do the trick. But the unit circle does. If I rotate 13 pi, isn't this 1 pi, 2 pi, 3 pi, 5 pi? Isn't all odd multiple of pi are right there? And isn't that negative 1, 0? Cosine of 13 pi is negative 1. Sine of 13 pi is 0. How about 12 pi? So it's all gonna be really down to where's 12 pi is right there. If it's any of these points, it's a unit circle. Cosine of 12 pi is 1 and sine of 12 pi is 0. And pi over 4, I know they're 1 over radical 2 each. And how do I know that? I'm very smart. No, well, if I draw the 45, 1, 1 radical 2. Sine is the adjacent over the hypotenuse, and cosine is the opposite over the hypotenuse. Where is 5? So there's always two questions in your mind. One, what's the value? And second, where am I? Where is 5 pi over 4? 5 pi over 4, this is 4 pi over 4. So 5 pi over 4 is a bit past that. And in this quadrant, aren't they both negative? Now I do want to point out, the book will rationalize those, and the answer would be, oops, I'm sorry, my hand hit that. The answer would be radical 2 over 2, radical 2 over 2 negative. You should rationalize, but you should also know that it is negative 1 over radical 3. I mean radical, negative radical, 1 over radical 2. Alright? So I didn't use those identities yet, but I derived them. We're going to be using them soon. And that's pretty much it for the rest of this section.